So last video we saw Naraba nice representation. The continuation For the continuation, it's a generation of quadrature components of N of t. So last video we saw Naraba nice representation. Now there is a continuation of video generation of quadrature component of N of t. So what we seen last video, you know, so there is a equation N of t that is representing Naraba nice representation. That N of t get a Hilbert transform. So the N of t equation we can change as N cap of t. So that N cap of t is mentioned as the cos value, because we know N cap of t is a 90-degree phase shift. So cos it is changed as a sine changed as a cos. So you see that previous equation that will be changed as x of t equal to the previous equation cos, here it is sine 2 pi of ct, then y of t, previous equation is sine, and here is cos 2 pi of ct. So now we have to quadrature component of N of t. So you know N of t is an Araband nice equation. So it's a generation of quadrature component. How the property, there are two signal here dealing with x of t and y of t. There are two signals are present here. So x of t and y of t. So the following properties. So e x of t and y of t both are 0. If it is 0, the exponents value of x of t and y of t, if it is 0, then y of t is uncorrelated with each other. You know what is correlation mean? Autocorrelation, covariance, everything we signed the add unit. And this x and y that is equal to 0, so uncorrelated with each other. If x of t and y of t have the same means and variance, here the property showing x of t and y of t have the same means and variance. The exponential value is 0, so it is uncorrelated, and x of t and y of t has the same means and same variance as n of t. If n of t is Gaussian, consider that narrowband noise representation n of t is Gaussian, then x of t and y of t also Gaussian. What is Gaussian? You know what is ergodic Gaussian process? It's unpredicted value, means we have to predict unseen places for taking average. So x of t, y of t have identical power spectral density that is related to the power density of n of t by gx of f and gy of f minus fc carrier frequency plus tn of f plus fc. So the x of t and y of t is identical. Identical means it's the same power spectral density. The property has the same mean, same variance. Even the n of t is Gaussian, then x of t, y of t also is a Gaussian. Then x of t, y of t, if it is the same identical power spectral density, then the equation is gx of f equal to gy of f. So the carrier frequency is 0.5 by 0.5 b, that is less than of f and less than of fc plus 0.5 b. So what is b here? B is nothing but bandwidth. So bandwidth of n of t. The in-phase quadrature components, sinusoidal components, the sine A plus B equal to sine A cos B plus cos A sine B. You know that the in-phase quadrature sinusoidal component represented in the equation A sine of A plus B sine A cos B plus cos A sine B. From the trigonometrical identification, we can change the equation to follow x of t. Finally the a1 cos omega t plus a2 sin omega t. This equation we just consider. Actually, our topic is in phase and quadrature components. So from these components, from this equation, we consider that sine part as a in phase component, and then cosine part considered as a phase quadrature component. Do you understand? So based on the equation, the sine part we can consider as a in phase, and cosine part we can consider as a phase quadrature component. So what is phase quadrature? This look like Hilbert transform 90-degree phase shift like that. Here 90-degree. So out of phase. So that's why it is cos means it is cosine. The in phase component that is represented as a sine wave. This sine is in phase, then cosine is part is phase quadrature. The phase quadrature means it's a 90-degree out of phase. So noise in AM receiver using envelope detection. So that is standard AM, both standard carrier transmitter AM wave written as S of t is equal to AC 1 plus KIM of the cos 2 pi FCT. This is we already seen from amplitude modulation from the first unit. So this is the equation is so. So from the equation, the narrowband equation they are drawing the diagram. So trigonometry, that triangular that representing the quadrature and the in phase components. We already saw it's a 90-degree phase shift is a cosine part. We can take as a in quadrature part, and in phase is sine part. So the continuation, the final equation is AC KIM of t plus N1t whole square. So the equation, so its average carrier power is large compared with the average noise power. Okay. The in phase quadrature component, the final, uh, the equation is shown. Uh, there are three functions in that waveform. The center frequency, the amplitude modulation. That in electrical engineering, a sinusoidal with angle modulation can be decomposed into or synthesized from two amplitude modulated sinusoidal waveform. There are three functions are playing in this waveform, such as amplitude modulated sinusoidal, also known as in phase and quadrature component. So there are three. One is amplitude modulated signal and the in phase component and quadrature component, and also center frequency also playing in the role. Okay, thank you.